Welcome everybody to the FP 101 Functional Programming MOOC. I'm really happy that we can do this one as a MOOC with exercises and everything. And let's get started immediately. One thing that I wanted to tell you before we get going is that this is a MOOC about functional programming. That's what the title says, FP 101 Functional Programming. So this is not a course on Haskell. We're using Haskell as a functional language, but we're not learning to program Haskell per se. Let me tell you a little bit of a story. I travel a lot, going to conferences, giving courses, etc. And during those travels, I have ample time to watch TV. And one night I was zapping through the channels, and there was one of those survival shows where this guy was trying to make up camp at night, trying to make a fire, but his matches were wet. Now, he could have gotten in panic and said, oh, my matches are wet, I cannot make a fire. But what he did instead is he took his cell phone and his knife, and he took the battery out of his cell phone, opened the battery, and then the battery started to combust, and that's what he used to start a fire. And this is the same attitude that I want to teach you in this course. While we're learning to do functional programming using Haskell, so Haskell are our matches, when at work you don't have matches available, you still can do functional programming. And sometimes you have to smash your cell phone and open your battery to start a fire. So don't think that this is about Haskell per se. We're going to teach functional programming using Haskell. All right, let's get started then. What's the problem that we're trying to solve? The problem is the so-called software crisis. We all know as developers that writing code is pretty difficult. We're writing huge programs, and what we need to do is to reduce the time and the cost of development. We want to deliver software fast, and we want to deliver correct software. The question is, how can we make programs such that we are confident that our programs work, and how can we make code such that this code is delivered fast? It doesn't take years to deliver, but it takes months or as long as it needs to be. One way to do that, and we see this now in all modern programming languages, is to add features to our languages that allow programs to be written clearly, concisely, and at a high level of abstraction. And the techniques that we use in these modern languages are all based on functional programming. These techniques are all based on concepts from the lambda calculus. And Haskell is a functional language that is pure and therefore a really good vehicle to teach these concepts. Functional languages, therefore, provide a very elegant framework to write code at a high level of abstraction. But as I said, Haskell is just our vehicle. So what we learn in this course, you will be able to apply this to any language, even if you're programming in assembly or in Java or in PHP or in JavaScript. All the ideas that you will learn here, you can apply immediately in whatever language you're happening to use. So what is a functional programming language? And the ideas about that vary, and there's no real clear definition. If we take a very purist approach, a functional language is a language in which we program using mathematical functions. And that definition applies to Haskell, which is a pure language, one of the very few functional programming languages that is pure. But of course, when I say that we can use these techniques to program also in other languages, we cannot use that definition. So what we'll use in this course is the following definition. Functional programming is a style of programming in which expressions are more important than using statements. So what we want to do is we want to compose programs using expressions, and these expressions deliver a value. So we take two expressions that deliver a value and compose them in a bigger expression. Compare and contrast that with writing your program using statements. When you compose statements, these statements have an implicit side effect on the global state, and so they communicate values via that global state. Whereas in an expression-based programming style, expressions return values, and we compose these values directly. So a functional programming language is a language that supports and encourages writing code using expressions. And as I said before, most modern languages now support this style. And they support this style specifically by supporting lambda expressions. And we will see examples of functional programming in many, many languages as we progress through this course. So let's start with our first fragment of code here. This is some old-fashioned Java, where we're computing the sum of the integers from 1 to 10. So the way we do that, as I said, in the traditional imperative style, this is based by doing statements. So the first thing we do is we declare a variable, total, of type int. We initialize it with 0. And then we write a for loop with a loop variable, that int I that you see there. And then we assign to that the total variable, total plus I. So here you see that the program is written in an imperative style. We have statements, we have mutable state, and we imperatively execute statement after statement, updating the state to compute the result. Now here is how you would write that same program in Haskell. So the first thing you see is that it's much more concise, but the other thing is that there's no statements, it's just two expressions. The expressions you see here on the right, 1.10, creates a list of the integers from 1 to 10. And then we just sum those integers up. So here you see that we're composing the code by having an expression, one that creates this list from 1 to 10, and then we apply that value to a function sum that will sum things up for us. Now in Java 8, you can write the same code using Java 8 streams. We will dive deeper into Java 8 in a future lesson, but for now, here is the way we do this in Haskell. Thank you, and see you in part 2.